Welcome to the lecture on rational expressions, finding domains, simplifying, multiplying, and dividing. To begin with, let's define what a rational expression is. A rational expression is any expression of the form p over q, where p and q are polynomials, and we're also going to require that q doesn't equal 0 because it's undefined if you have a 0 in the denominator. So when we talk about rational expressions, we're looking at polynomials divided by polynomials. Rational is just kind of a fancy word for fraction. So we're going to be dealing with fractions. Now the first thing we're going to be doing is finding the domain of a rational expression. And when you talk about a rational expression, since it's a fraction, remember that fractions could possibly have zeros in the denominator for some values of x. So what we're going to do to determine the domain of a rational expression is find out where that denominator might equal 0. So how do you do that? First, you're going to factor your denominator completely. Then you're going to set each factor of the denominator to 0, and your domain is going to be all real numbers except those places where the denominator was 0. So for example, if I have 4 over x plus 2, we have x plus 2 in the denominator. Now that doesn't factor any further. It's already a linear factor, so we don't have to worry about step 1. All we have to do now is take that denominator, set it to 0, and find where that denominator might become 0. So if I subtract 2, then when x is negative 2, if I were to plug that back into the original fraction, we're going to get something that's undefined. So what we say is that our domain is all real numbers, except negative 2. If you want to write your domain as intervals using interval notation, then the way that would look would be the interval minus infinity to negative 2, parentheses, union, negative 2 to infinity. So our domain is all the real numbers, and all I've done is left a little tiny hole right at negative 2, and that hole is there because I have an open parentheses around the negative 2. You would not want to use brackets, otherwise you'd be including that bad point. Okay, so if we look at this next example, we're going to do the same thing. When you're looking for the domain of a rational expression, you're only worrying about the denominator, so it doesn't matter what the numerator is at all. So if we look just at the denominator, x squared minus 4, you should recognize that that is a difference of squares. It's a square minus a square, so that means it does factor. So let's go ahead and factor it. We're going to get x's in the front, 2's in the back, 1's plus and 1's minus, so that we get no middle terms. Once we have the denominator factored, we're going to set it to 0 to find our bad points, the numbers that would make the denominator 0. If I set this factor to 0, I'm going to get negative 2. If I set this factor to 0, I would get positive 2. So our domain would be all reals except plus or minus 2. If you want to use interval notation, then you're going to have the intervals minus infinity to negative 2, union negative 2 up to positive 2, union 2 up to infinity. So our domain is all the real numbers except negative 2 and positive 2 because I've left a hole at negative 2 and a hole at positive 2. Alright, so let's try another example. If I see this rational expression, again, disregard the numerator. We're only worrying about where the denominator could equal to 0 if we're looking for a domain. So I want to take this trinomial, which has 3 terms, and see if I can factor it. Because it has 3 terms, we're going to try reverse FOIL. So set up your 2 sets of parentheses. I need 2 numbers that multiply to 2x squared. So that could be 2x times x. And then I need 2 numbers that multiply to 3. That could be 3 and 1, or it could be 1 and 3. So to see which one we want, we're going to check our outers and our inners. 2 times 1 would be 2. 3 times this 1 here would be 3. Can I get a 5 out of that? Yes. If I make them both plus, I'm going to get a plus 5. So the denominator does factor into 2x plus 3 times x plus 1. Now that we have the denominator factored, we're going to set it to 0 and set each factor to 0. So 2x plus 3 equals 0 at negative 3 halves, and x plus 1 equals 0 at negative 1. So our domain would be all reals except negative 3 halves and negative 1. Using interval notation, negative 3 halves is more negative further to the left on a number line, so you'd want to do minus infinity to negative 3 halves, union negative 3 halves up to negative 1, union negative 1 up to infinity. Okay? On the last example here for domain, to find the domain of the fraction, disregard the numerator, and we're trying to find out where that denominator would equal to 0. Since this is quadratic, we might want to try and factor it. We have a square plus a square. Unfortunately, this doesn't factor because it's not a difference of squares, it's a sum of squares. So this won't factor at all. There's no GCF, and we have no other techniques to use if it's not a difference of squares. So since the denominator doesn't factor, we would just want to see, well, where could it equal to 0 as is? If I didn't factor it at all, where would it equal 0? If you try to solve x squared plus 4 equals 0, bring that 4 over to the right side, and then take a square root of both sides to try and solve for x, and hopefully you can see that right away this does not exist. We're not allowed to take the square root of a negative number, so what that means is that this equation, x squared plus 4 equals 0, has no solutions. So there's no numbers for x that will make that denominator 0. So what does that mean in terms of our domain? If the domain is never 0, then we never have any bad points. So there's no points that we have to leave out. So our domain is going to be all reals. There's no exceptions. There's no numbers that are bad. How do you write that as in interval notation? You would write it as negative infinity to positive infinity. So we include everything. Okay, so the first thing you need to be able to do with rational expressions is to find their domain. You're going to factor the denominator completely, set it to 0, and your domain will be all reals except where those factors equal 0. The next thing that you have to be able to do with rational expressions is simplify them. This time when we go to simplify, we are going to be looking at the numerator as well as the denominator, and we're going to always start by completely factoring everything in the top and everything in the bottom. Once we have it completely factored, then we're going to cancel out any common factors with a positive 1, or cancel out any opposite factors with a negative 1. And our answer is going to be all the terms that are left, all the factors that are left. So, for example, if I have 5s minus 25 over s squared minus 25, it's very tempting to want to cross off these 25s right away. However, you cannot cancel out sums or differences. You can only cancel out factors, which are products. So before you can cancel anything out, you must factor first. So looking at this numerator, how could you factor that numerator? Well, 5s minus 25. Both of those coefficients are divisible by 5, so we could pull out 5 like a GCF, and that would leave us with s minus 5. In the denominator, we have s squared minus 25. That's a difference of squares pattern, a square minus a square. So we can factor that using two sets of parentheses, s's in the first spot, 5's in the second spot, 1's plus and 1's minus. So it's at this point, after you have completely factored, that you can start crossing things off. You are not allowed to cross off until you've factored first. And what we're looking for are things wrapped in parentheses that are the same on the top and the bottom, or possibly opposites on the top and the bottom. In this case, s minus 5 and s minus 5 are exactly the same, so they're going to cancel out to a factor of 1. So our answer is going to be whatever's left over. We have a 5 left on top and an s plus 5 on the bottom, and here's our final solution. Don't be tempted to try and cross off these 5's because they are not part of the same factor. You would need the top to be s plus 5 as well. You can't sort of break up a sum down here in the bottom and just cancel out part of the sum. Okay? So let's try this again on the next example. Before you do any canceling at all, always factor. So looking at the top, what could I factor out of the top? They both have 6's and they both have t's. So my GCF is 6t. If I factor that out, this 6 is gone, one of these t's is gone, so 1t is left. From this term, the 6 is gone, the t is gone, so all I have left is a minus 1 factor. In the denominator, 2t minus 2, both of those have a 2 in common, so I can factor out 2, and that's going to leave me with t minus 1. Now that we've factored, we're ready to cancel. Notice that t minus 1 on the bottom is exactly the same as t minus 1 on the top, so that'll cancel to a factor of 1. And don't stop here. Look at these coefficients out front. 2 divides into 6 3 times. So what's left is our 3t, and that will be our final solution. Okay, in our next example, we want to factor first. So don't be tempted to cross off these 3x squareds. You're not allowed to do that because they are part of a sum or a difference. So we have to factor. To factor the numerator, we have 3 terms. So we need to use reverse FOIL. And I need 2 things in the front that will multiply to 3x squared. So that's going to have to be 3x times x. In the second position, I need 2 things that multiply to 4. That could be 2 and 2, it could be 1 and 4, or it could be 4 and 1. With a little trial and error, we can see that it's got to be 2 and 2, because then my inners will be 2x, and my outers will be 6x, and that adds to 8x. So if I make both of these plus, I'll get the correct middle term. In the denominator, we're going to do something very similar. 2 sets of parentheses. We need 2 things that multiply to 3x squared, so 3x and x. And this time, to get a negative 4, I'm still going to use 2 and 2, but I'm going to put a plus in front of the first 2 and a minus in front of the second 2, so that my inners will be plus 2x and my outers will be minus 6x, and when you add those together, we get negative 4, which is exactly the middle term we were looking for. So this is how it factors. Now, when we go to cancel things out, 3x plus 2 is exactly the same as 3x plus 2 on top, so we can cancel those out. What we're left with is x plus 2 over x minus 2. Now, those are very similar, but because that middle sign is different, they are not equal, and they are also not opposites. To be opposites, the signs of both terms would have to be different on the top and the bottom, and that's not the case. So even though they're really close, x plus 2 over x minus 2 doesn't cancel out at all, so that's just our answer. Okay, next example, we're going to factor the top as much as we possibly can. We have 3 terms, so I'm going to use reverse FOIL. I need x times x in the front to get x squared, and then I need 2 numbers that will multiply to negative 6 and add to a positive 1. So that's going to have to be a 3 and a 2. If I make the 3 plus and the 2 minus, plus 3 minus 2 is a positive 1. So I'm getting the correct middle term. And a plus 3 times a minus 2 is a negative 6, so I also have the right last term. So we factored it correctly. In the denominator, we have 4, which is a perfect square, minus x squared, which is another perfect square, so we have a difference of squares pattern. So I can set up my 2 sets of parentheses. I need 2's in the front, x's in the back, 1's plus, and 1's minus. Now when we go to cancel here, the x plus 3 is different from all the rest of these, so that one's going to stay put. X minus 2 is almost the same as 2 minus x. what you can note here is that x minus 2 is the opposite of 2 minus x. If you were to redistribute that negative across, you'd get negative 2 plus x. And if we switch the order around, because addition is commutative, we can do that, we would get x minus 2 back. So x minus 2 and 2 minus x are actually opposites. So we can cancel them out, but because they weren't exactly the same, they were opposites, we get a factor of negative 1 left over. So when I go to write my final answer, we're going to have x plus 3 on top left over. We're going to have 2 plus x on the bottom. And don't forget that negative. What I usually do is I put it out front. That just makes it easier. Other options is you could put it in the top, but if you put it in the top, you would want to wrap that x plus 3 in parentheses. Or you could even put it in the denominator, but then you'd need to wrap 2 plus x in parentheses. So these are all options. I think this one is easiest. I like to put the negative way out front. Okay, so let's kind of review really quickly here what you're allowed to cancel out and what you're not allowed to cancel out. If the top and the bottom are exactly the same, you can cancel them out and get a factor of 1. So x minus 2 is the same as x minus 2, so this is going to reduce to 1. X plus 2 over 2 plus x. Be careful with this. They look a little bit different because the order is reversed, but remember that addition is commutative. So 2 plus x is really the same as x plus 2. So the top and the bottom really are identical. So this does factor or does reduce to positive 1. In the next fraction, x minus 2 over 2 minus x, they are both minuses, but the signs of the top and the bottom are switched. On the top, the 2 is negative. On the bottom, the 2 is positive. On the top, the x is positive. On the bottom, the x is negative. So these are considered opposites, so they do cancel out, but you get a factor of negative 1 left over. Then for this last fraction, we have x plus 2 over x minus 2. If the two middle signs are different, then this will not reduce at all. So this is just going to stay x plus 2 over x minus 2. So if you look back at these first three, you have to have minus minus or plus plus if any kind of cancellation is going to occur. If you have opposite signs in the middle, then it's not going to reduce. Alright, let's look at a little bit more complicated examples. On this first one up here, the numerator here is a plus b quantity squared. A lot of times students will be tempted to FOIL that out, but you actually don't want to because this is already factored. Remember, something is factored if it's in parentheses. So don't undo all this hard work. It's already done for you. You don't need to factor it at all. So you can leave it as a plus b squared. Another option, if you prefer, is you could write it as a plus b times a plus b. That way you can see the individual factors themselves. But do not FOIL it out, because then you would just have to reverse FOIL back to put it into factored form. The denominator doesn't have any parentheses, so that does need to be factored. So we're going to need two sets of parentheses. We need two things that multiply to a squared, so that has to be a and a. And we need two things that multiply to 3b squared, that has to be 3b and b. And if we want to get a negative 2ab in the middle, then I want the larger number to be negative, so the 3 should be minus and the 1 should be plus. And that will give us the correct signs and the correct middle term. So here's your two options of how you could write this. Once it's factored, we're ready to cancel things out. And if you think of it in this form, one of these a plus b's on top cancels out with one of them in the bottom, but we'll still have one left in the top. Or over here you can just see that these are going to cancel out, but I still have one left on top. So our final answer is a plus b over a minus 3b. Okay, on the next example we're going to do the same thing, but the factoring that we use here is a little bit more complicated. If you look at the top, There's no common GCF straight across, so then we count terms. There's 1, 2, 3, 4 terms. And if you remember from our notes on factoring, the method to use when you have 4 terms is grouping. So we're going to try the grouping method on the top and on the bottom. So the way grouping works is you group together the first two and the last two and try to pull out a GCF just from the first two and a GCF from the second two. So let's start with that. From the first two here, 8x plus 16, there's an 8 that I can pull out. If I pull that out, I'm left with x plus 2. From the second two terms, they both have p's and they both have negatives. So I am going to pull out a minus p. If I do, I'm left with just the x and with a positive 2. If you're doing this correctly, this grouping method, then what you have in parentheses here should always match what you have in parentheses here. So there's a second step to our grouping method. Once we see that these two factors match, pull out the x plus 2, think of crossing them off, and in a second set of parentheses you're going to write what's left over. So in this case, that's 8 minus p. So our grouping method on top is actually 2 steps. First you pull out your GCF, and then you pull out the common factor. Now we're going to do that all over again, but in the denominator. So if I group together these first two terms, they both have a p, and I would be left with x minus 2 if I pull it out. These two terms both have an 8 in common. Notice that I want to end up with an x minus 2, so in order to make the signs correct, I'm actually going to need to pull out a negative 8 so that I end up with a positive x and a minus 2 left over. I want these two factors to match exactly, so that's why we pulled out the negative. Since they match, I can factor it out like a GCF, imagine crossing it off, and what we're left with is p minus 8. So now we have completely factored the top and the bottom, so we're ready to try and cancel things out. X plus 2 and x minus 2 are close, but they do not cancel because the signs in the middle are opposites. For the 8 minus p and the p minus 8, they are both subtractions, so they should cancel out, but because the order is reversed, they're actually opposites, so we do cancel them out, but we will have a factor of negative 1 left over. So our final answer is going to have that x plus 2 on top, that x minus 2 on the bottom, and that negative 1 that we got, just stick it out front. So our solution is negative x plus 2 over x minus 2. So far with rational expressions, we've talked about domains. That's where you set the denominator to 0, factor it, and set each factor to 0. And your domain is all reals except where the denominator would equal 0. Next, we talked about how you simplify these rational expressions. Again, you factor both the tops and the bottoms, and then you cross off either common factors or opposite factors. Multiplying and dividing rational expressions is extremely similar to simplifying rational expressions. Instead of just dealing with one fraction, however, we're going to have 2 to deal with. So we're going to make sure that we completely factor all of the numerators and all of the denominators, and then we're going to cancel any common factors that we have across any of the tops with any common factors that we have across the bottom. So for example, if we start with the upper left polynomial here, 12x minus 20, to factor that, it probably has a GCF. So if we think about what number goes into 12 and 20, they're both divisible by 4. So if I pull out a 4, then I'm going to be left with 3x minus 5. The denominator, 5x, is just a single term, so it's not factorable. I'm just going to leave it as a 5x. Then when I go to the upper right, same idea. 6x squared is a single term, a monomial, so it's just going to stay 6x squared. But the denominator, the bottom right, 9x minus 15, both of those numbers, 9 and 15, are divisible by 3. So if I pull out a 3, then I'm going to be left with 3x minus 5. So now when we go to simplify, because multiplication of fractions you do top times top over bottom times bottom, we can really just think of this as one great big division bar, and everything on the top is getting multiplied together and everything on the bottom is getting multiplied together. So when we go to cancel out, anything across any of the tops that cancels with anything across any of the bottoms, you can cancel out. So this 3x minus 5 cancels with this 3x minus 5. Then we're left with a 4, a 6, an x squared, a 5x, and a 3. Those can also potentially cancel as well. We know that 3 divides into 6 twice, so we can cancel that out. 5 does not go into 4 or 2, so I think all of our numbers are simplified, but I have a single x in the bottom and an x squared on the top, so this x from the bottom is going to cancel and leave me with one x left on the top. So we're left with a 4, a 2, and an x on top, and a 5 on the bottom. So to get our final answer, remember, top times top. So 4 times 2 times x would be 8x, and on the bottom, the only thing we have left is that 5. So our final answer, 8x over 5. For the next example, this is now division. So in order to simplify this, what we're going to want to do first is remember that when you divide fractions, that's exactly the same as multiplying by the reciprocal. So the very first thing we're going to want to do is get rid of this division symbol and change it to a multiplication by the reciprocal. So when you do that, the first fraction does not change. So I'm going to recopy this first fraction exactly as it is. And then I'm going to change this division symbol to a multiplication and flip over the second fraction, z plus 1 over 1 minus z. Now we're ready to treat this problem just like the last one. So the next thing that we're going to want to do is completely factor all of the tops and all of the bottoms. So the numerator here on the upper left is a trinomial. So if I use reverse FOIL, set up two sets of parentheses, I know that I need a z times a z to get z squared, and then I need two numbers that multiply to 2, positive 2, and add to a negative 3. So the only way to get 2 is 2 and 1, and I need to make them both negative so that when they multiply I get positive 2, but when I add them I get negative 3. If I go to the bottom left, z squared plus 4z plus 3 trinomial, so I'm going to set up two sets of parentheses. I need a z and a z to get z squared. To get 3, I need 3 times 1, and in order for those to add up to 4, I need both of them to be positive. So all the top left and top bottom are factored. If I go to my second fraction here, z plus 1 is already done. It doesn't have a GCF and it doesn't factor any further. And the bottom right also doesn't have a GCF, so it's done as well. So to finish it off, again, think of this as just one big fraction bar. So if I see anything on the top that cancels with anything on the bottom, I can cross it off. And if you want, you can put parentheses around that z plus 1 and that 1 minus z. So I see a z plus 1 on the bottom and on the top that I can cancel out. And then if you look across the top here, I have a z minus 1, but on the bottom I have a 1 minus z. Those are your opposites. Remember, they should look exactly the same with the order flipped and subtraction in between. So I can cross these off, but I'm going to be left with a factor of negative 1. So when I look at what's left, z minus 2 does not match z plus 3, so those are going to be left over. And that minus 1 that I got when I canceled out my opposites, you can just stick that negative way out front. So here's my final answer. Okay, let's try another division problem here. Now before anything else, always flip first. Otherwise you're going to forget to do that and it's going to mess everything up. So the top or the first fraction stays the same. You don't do anything to it but recopy it. And then we change our division symbol to multiplication and we flip over our second fraction. So it becomes x squared plus 3x plus 2 over x squared plus 2x plus 1. Now we're ready to factor everything that we can. Now remember, we had an example earlier that was like this. If you look at the top left, this already has parentheses in it. So please do not try to FOIL this all out. That's just going to take you a lot of time to do, and it's wasted effort because it's already factored. So when you see parentheses in your problem, leave it alone. Just recopy it. It's already factored, so that top left is done. To factor the bottom left, we have a trinomial, so I need two sets of parentheses. X times x is x squared. 4 times 1 will be 4, and 4 plus 1 add to 5. So I'm going to need an x plus 4 and an x plus 1. And these factors can go in either order. For the upper right, another trinomial, so two sets of parentheses. I need x times x to get x squared. 2 times 1 is 2, and if I make it a plus 2 and a plus 1, I'll get that middle term of plus 3. On the bottom right, another trinomial, so two sets of parentheses. X times x is x squared. 1 times 1 is 1, and if I make it plus 1 and plus 1, I'll get plus 2 in the middle. So now everything is completely factored. We are ready to start canceling things out. So the first thing I see is an x plus 4 on top and an x plus 4 on the bottom. So those are going to cancel out. Now I have a bunch of x plus 1s on the top and a bunch on the bottom. You can cancel out any of them that you want. However, you just want to keep track. If I count the ones I have on the bottom, I've got 1, 2, 3 x plus 1s. I'm going to cancel those 3 out with all 3 of these. If you prefer to cancel out this x plus 1 on the upper right with one of the ones on the bottom, that's fine. Then you'd cancel the other 2 with 2 of these and have 1 of these left over. So in any order, it doesn't matter how you do it, as long as you keep track of what's left. So if we look at what's left, all of this is gone, and the only thing we have left is this upper right. So my answer is x plus 2 times x plus 1. Okay, the last example, another division problem. So the first thing we're going to do is flip first, so we don't forget. So we leave the top left as is for now, and the bottom left as is. Change the division to multiply, and flip over the second fraction. So we get 2x squared minus 9x minus 5 over x squared minus 25. Now we want to factor. Now this particular example has a little bit tougher factoring. What you need to remember for the upper left is the formula for a difference of cubes. And if you remember that formula, what it says is if you have a cube minus a cube, then the way that that factors is you get 2 factors. The first factor is the cube root of the square minus the cube root of the triangle. And the second factor actually has 3 terms. It's the square squared, the triangle squared, and the middle term is these 2 multiplied together. And then for your signs, they need to alternate. So if this is a minus right here, then you need the opposite sign for the middle term, and the sign on the triangle squared is always positive. So we're going to put that pattern into use for our x cubed minus 125. So the cube root of x cubed is x. The cube root of 125 is 5, and since this was minus, I have a minus right here. For my second factor, I'm going to square the x, which is x squared, square the 5, which is 25, and that's always positive, and your middle term is these 2 multiplied together. So that's just going to be 5x. Notice here we're not doubling that middle term. And then since the first factor was minus, the second factor has to have plus, so that those signs alternate. If you really wanted to, you could FOIL this all back again and double check that you get x cubed minus 125. So there's our difference of cubes. In the denominator, we have 2x plus 1. There's no GCF there, and it's a linear factor, so we can't really do anything with it. It's already in factored form. So let's move to the upper right. 2x squared minus 9x minus 5. That's a trinomial, so we need reverse FOIL. I need 2x times x to get 2x squared, and I need 5 times 1 to get 5, but I could either put the 5 here and the 1 here, or the 1 here and the 5 here. It has to be 1 here and 5 here, so that we get 2 times 5 is 10, and 1 times 1 is 1, and that's going to give us the 9 that we need in the middle. In order to get a negative 9, I want the 10 to be negative, so the 5 has to be minus, and the 1 has to be plus. So we're going to get the correct middle term. Bottom right, if we factor that, we have an x squared minus 25. That you want to recognize as a difference of squares. So we're going to have parentheses, x and x, 5 and 5, 1's plus, 1's minus. Finally, we have it all factored. We're ready to try and cancel out whatever we can. I see an x minus 5 on the top here. That will cancel with this one on the bottom. You could also have canceled the one over here with the one on the bottom. It doesn't matter which one you use. We also have a 2x plus 1 on the bottom, which cancels with this 2x plus 1 on top. And this x minus 5 does not cancel with the x plus 5 because the signs are different. So our answer is going to be x minus 5, parentheses, x squared plus 5x plus 25, all over x plus 5. We had this and these two left over. So here's our final answer. And you want to leave your answer in factored form. You don't need to bother redistributing. It's best to leave it in factored form. Alright, that concludes our notes on rational expressions, finding domains, simplifying, multiplying, and dividing. Good luck.